Good afternoon, everyone, and welcome to this new Progold webinar. In the jewelry world, the ultimate goal has always been the pursuit of aesthetic perfection, creating pieces that represent a balance between beauty and quality. However, even in the most controlled production process, imperfection can still occur. Very often, the real challenge is not the defect itself, but the difficulty in understanding its origin. And this is exactly the starting point of today's webinar. Our goal is to explore 4 common defects in the jewelry product, focusing not only on how they appear, but most importantly, why they occur and how they can be understood and prevented through a structured approach. We will begin with a brief introduction about who we are, what we produce, and the value we bring to our customer. They will look at why defect represent such a critical aspect in the jewelry manufacturing. In the central part, we will analyze 4 selected defects, and finally, we will conclude with key takeaways and an open discussion. My name is Riccardo Cavinato, and I am the Jewelry Metallurgist Manager at Progold. My role, together with my teams, is to support customers in improving their production processes in order to achieve the best performance from the alloys they are working with. This includes identifying production issues, understanding their root causes, and supporting the implementation of long-term solutions. Our company was founded in the 1997 and has developed over time a strong and structured presence within the global jewelry industry. Today, we operate through a strategic network of dealers that allow us to stay close to our customer worldwide. We specialize in development and the production of alloys, master alloys, and soldering products, designed to meet the best performances in terms of quality and process reliability. At the same time, we are also active in additive manufacturing, supporting the evolution of production technologies within the industry. This combination allows us to address both traditional and innovative manufacturing approaches, providing solutions aligned with the continuously evolving demands of the market. Beyond products, our real added value lies in the technical consultancy. We work closely with our partner, not just a simple supplier, but as a partner. We support them in optimizing material performances and improving production process in terms of efficiency, consistency, and overall quality. This is made possible through our 30 years technical know-how and the use of advanced analytical instruments. In this way, we do not simply respond to problems, but actively contribute to improving our customer processes and results. But why defects do matter? In the jewelry industry, aesthetic quality is essential. Even a small imperfection can significantly affect the perceived value of a product. However, the impact of an imperfection goes far beyond appearance. Production issues directly influence cost, efficiency, and scrap reusing, and very often these challenges are addressed through a trial and error approach, which may lead a temporary fix, but rarely to stable solution. The key message here is simple. A defect is a symptom, but not the root causes. Without a clear understanding of its origin, it becomes very difficult to take active actions. To better understand the real challenges faced by the industry, we engage directly with professionals through a LinkedIn survey, asking them to identify the most common defect in the jewelry manufacturing. The 4 defects we will discuss today were selected based on this interaction, as they represent the most voted and most frequently mentioned topics by industry professionals. First defect that we will discover today is related to the platinum brittle fracture. In this case, we are going to see a defect that regards a ring produced by platinum, but this kind of defects also could affect gold and silver product. How to recognize this kind of defects? Typically, the brittle fracture occur with a morphology of intergranular cracking, and generally are localized in a particular part of the rings where stress generated during cooling or soldering start this fracture. Which is the main causes of this defect? First of all, contamination of brittle elements could decrease the mechanical resistance of the material. But not only contamination, also an inadequate feeding geometry of the model could affect this kind of issue. How to solve this kind of problem? First of all, the purity of the metal is crucial in order to guarantee the resistance of the material. Contaminated elements like aluminum, silicon, and carbon are dangerous and could derive from the contact with the crucible and investment used for the production of this material. But also, even in particular in the new model design, needs to be studied an adequate feeding system in order to prevent from the localized stress that could bring to the cracking. The second defect that we will see today is the hard spot. Hard spot is, in this case, we will see a defect produced in the 18K red gold on a ring from investment casting. But this kind of defect also affect silver alloy and the other kind of color and cartridge. How to recognize the hard spot? Hard spot is typically generated like an localized with high hardness inclusion above the surface and on the volume of the item, and it is easily recognizable with the comet-like effect. The critical point of the hard spot is that appears just on the final part of the production process and after polishing. So just on the final part of the finishing of the item, hard spot appears. Which is the cause of this defect? Mainly, this defect could be generated by an external contamination generated by the contact with the alloy with another kind of elements that present during the production process. The solution will be avoid the contamination on using dirty scraps that comes from different production process, or use the same crucible for different kind of alloy. In particular, this kind of issue could derive from alloys that has a different kind of grain refinery inside. Another root case could be due to non-homogeneous melting. Since the hard spot is generated during the melting and the solidification, it is better to advisable a pre-melting procedure before the casting in order to homogenize as it's best the metal during the melting. In this situation, and in order to prevent this kind of issue, it is advisable to use a detailed and developed alloy for both mechanicals and casting. The third defect that we will see is the orange peel. Orange peel is a defect that regards the plastic deformation process. What we are seeing is a solid chain produced in yellow gold in 10K that shows this typical morphology that calls orange peel. It's like the surface of the orange fruit, and that is similar to this quality surface, and affect the quality and the brightness of the mechanicals on the wire and the sheet after annealing and deformation. This phenomena appears after during the production process of annealing and deformation, and the main causes is due to the over annealing and the excessive grain growth during the production process. How to avoid? The solution is the optimization of the plastic deformation process, and here the technical consultancy could help you to solve this kind of problem, because knowing the behavior of the material is the first passage in order to not have this kind of imperfection. And the second part is choose an adequate alloy for the mechanicals. You could find in our products Genia and Flexia family in order to improve your production quality. The last defect that we will see today is the tarnish defect. Tarnish is a common defect of the silver alloy that affect the surface in terms of discoloration and loss of brightness, generating a non-uniform surface appearance. For this kind of defect, it is important to underline that tarnish is the low temperature oxidation of the surface that could occur during the usage and exposure of the item. And here it is important to differentiate the other common defect, that is the Firestein, that regards the oxidation of the silver alloy during the solidification. So it's an oxidation at high temperature. Which is the root causes of this defect? Sulfur-containing environment and oxygen in combination with chlorine and UV light could affect the surface of the silver item a long time. And this kind of defect is something that could be just solved with a strictly designed alloy like our Genia 276 that is developed in order to resistant to the tarnish. So, in conclusion, what we can learn from analyzing this common defect? A structural methodology is what ensures consistent and reliable results. And this is where technical consultancy truly make the difference. Production issue should not be seen simply as a problem to fix, but as a signal that something within the process needs to be better understood. Identifying the root cause is essential to achieve stable and long-term solution, supported by both experience and detailed analysis. If you are facing similar challenges, we invite you to contact us through our technical support portal. Our team is available to support you in analyzing your specific case and working toward effective and long-lasting solution. Thank you very much for your attention. I will now be available to take your question and discuss any specific challenges you might be facing. In 2 minutes, we will see all of your questions in the Q&A section. Okay, welcome back, and let's see the first question. Murtuza, how to tell differences between Firestone and tarnish? Okay, Firestone and tarnish could be differentiated, recognized with the morphology through optical microscope, but also scanning electron microscope could help in order to understand the composed element over the surface. But first of all, through a morphology identification, it is possible to recognize the morphology. In case of Firestone, Firestone appears like a opaque cloud over the surface in the most dense volume of the item where the solidification finish and generate copper oxide above the surface. In the case of tarnish, the defect is a little bit different, and stains above the surface could appear after even long period of time. So the first differences is the timing on this defect appear. In the case of Firestone, defect appears during the solidification, and after polishing, you could easily identify it. In the case of tarnish, you could recognize also over time. Next question. What methods can be used to determine which contaminant elements are causing the formation of hard spot? Hard spot identification needs to be scanning electron microscope and optical microscope in order to identify it. Scanning electron microscope could help us to go deeply on the morphology of the defect and also analyze the composition of the defect itself and help us to identifying if there is another external elements like iron or the other grain refiner that agglomerates together with the grain refiner of the alloy and generate the hard spot. So it is difficult to analyze this kind of defect by naked eye, and an advanced instrument like scanning electron microscope needs to be used. We are using Genia 143 for silver and facing Firestone after casting process, and also fast tarnish. Okay, in this situation, it is advisable to try to lowering down as much as possible the time of exposure, the metal, to a not temperature. So the first suggestion is to cut off timing before quenching the flask during the solidification, and also try to reduce as much as possible flask temperature and metal temperature. The thing is that since Firestone is an oxidation that occurs with high metal temperature and oxygen, it is also advisable to maintain the flask after casting inside the casting furnace in order to prevent the contact between oxygen and the hot metal. The fast tarnish could also be solvable in order to and could be advisable to clean as much as possible the item after the polishing phase with detail solution in order to prevent the contact of the surface with acid used for the production, and maintaining in a safe environment in order to protect it from the environment, from the external environment of the surface. Would cleaning silver with nitric acid be the best way of getting rid of tarnish? In this situation, the problem regarding the tarnish is related to the external environment. Nitric acid could help to clean the surface, but doesn't solve the problem itself. The solution of this problem, as we said in the presentation, is choose an alloy that is developed to resist and to the tarnish phenomena. In any case, if you had any kind of defect and you want to understand detailedly this kind of issue, you could contact us through our technical support portal. How can avoid fire stain? Okay, as I explained, fire stain could be avoid working on the temperature and on the protection of the metal from the oxidation during the solidification. So, leaving the flask inside the casting furnace during the cooling could help to prevent the contact with the hot metal to the oxygen, and also cutting the time between casting and flask quenching. How can the difference between forest in tarnish be identified? In this situation, okay, it is different between forest. Okay, this is curious. Okay, tarnish will be visible by naked eye on a silver surface, and especially could appear over time. The first thing to be advisable is maintaining the item in a clean environment and prevent the contact with the acid surface. If platinum cracks during casting, can it be reused for casting? It is dangerous to use cracking scraps with platinum, because it is not sure if these kind of defects could be related to a contamination or a wrong design of the item. So in this case, it is better to isolate the issue, starting with 100% of fresh material, and check if the problem will be solved. And then, after check this kind of results, try to introduce little amount of scraps in the next casting, in order to check if there is an issue of contamination. In any case, it is advisable to confront with us, with our team, in order to organize also an analysis of the material used, in order to check possible contamination of the material. What can be done if you find hard spot in casting? Will it help if we remelt at higher temperature? In this case, higher temperature doesn't help the hard spot appearance, because it is in this situation, hard spot most of the time could be generated by contamination. Better to higher temperature, it is advisable to provide a better homogenization of the material. So apply a pre-melting procedure before the casting, or increasing the time of mixing before casting in order to homogenize the material. The advisable solution when you find hard spot is start to 100% of fresh metal in order to check if a contamination could appear in your production process. Thank you very much for your time, and thank you for your presence.